Hello and good day once again. In the last video, I've introduced you to Boolean logic and Boolean logic gates. In this video, as a continuation of our series in Boolean logic in the Intro to Computing class, I'm going to introduce to you an online simulation tool which we can use in building or creating Boolean logic circuits. It's called Circuitverse. To access Circuitverse, you have to open your browser and head over to circuitverse.org. Circuitverse.org. Once it opens, you can click the Launch Simulator button. Now you are being introduced to the Circuitverse main panel. You can sign in if you want, so that you can have certain privileges such as saving into the online website of Circuitverse. But we don't have to do that. In this example, we're going to start with renaming our project. So for example, in this screen, you are given the following circuitverse main panels. Okay, this is the circuit board itself where you draw your circuit, and you have a circuit element panel which you'll use to pick elements that you want to place to the circuit board. Now on the right, you have a properties panel where uh, you define the properties of every element that you place on the circuit board, including the properties of the project itself. So the first thing that we need to do is name our project. For example, we'll name it as a sample project. Okay. So that's the first thing we can do. We can also attach a text component into our circuit board. We head over to the circuit elements panel, and there's an annotation button. We click the downward button and click the T icon. It stands for text. Okay. Once you have the text panel, you will have the properties changed here. You can type the property here, such as sample, and then you can do things such as increase the size. Okay. For the circuit. Basically, every circuit will have its input. It is where we derive our input variables in a Boolean circuit. So to put an input element, we head over to the circuit elements panel and click the down button for the input uh, choice. And then there are several input elements that you can have. The most common one is the uh, block border rectangle, which stands for the input. Okay, we can drag it over there, and then we can name it a label such as Y. Okay, now we can manipulate this by changing its orientation, either going down, going left, or going right, or up. And then you can also assign a label such as input Y. We can change also the label direction, in which case, such as up, like that. That's how you manipulate an input. And then we can also place an output by clicking into the output button. The output is usually a red bordered rectangle triangle. We drag it there and put it in our circuit board. We can put it a label such as Z. Click it here and then put the label. Like the input element, you can also change the label and the direction and the orientation. You can also change the unfortunately we cannot change the font size, but we can expand by scrolling our mouse, and then we can drag down by clicking the shift key to drag ourselves into the correct location in our circuit. Now we have grid lines which you can choose to align your elements and to make connections. Okay, uh, you don't have to use an element, but you can drag down on connection points. The connection point is usually that small green button attached to each element. Okay, so if you have something like that, you can drag it and place it there into and connect it to another component. So in this case, if we set y as 1, the output also becomes 1. When we set y as 0, the output also becomes 0. We can also include multiple outputs such that we can have another output here such as we name this as x, and then you can connect this to the line attached to the first output. That same thing will do the same connection even without that connection button on the line. You can just tap or attach to the line by dragging a connection to that line. Okay, now let us proceed to a more complex example. Let us create a circuit for a boolean expression. Let's do that on another sheet. We can create another sheet by clicking the plus button over there below the main menu. Okay, and then give a name. So we say we'll name it as our no, our from our equation itself. Y equals ABC plus BC plus not B. Okay, that's the name of our circuit. We can also place an annotation by dragging a text element there and put our paste our title. Now we can change the font size. Okay, and let us build the element, or rather the circuit. The first is we will have an output y. We will get the output from output. Okay, and then we'll give it a name y. I think the orientation, capital Y, the orientation of the component itself and the label direction is okay. Now we will put input lines that we can use to tap. So for example, we can go to our input button and then put a put three inputs there. However, we would like the orientation of this input to go downwards and the label direction to be up. Okay, because for example, we'll name this as A. Then we can just copy this, okay, by clicking outside and then doing clicking a rectangle, holding down the shift key and press Control C. We can also press Control V. Now we can drag this. We'll name this as our B. And then we can Control V again, that repeats. And then we name this as our variable C by changing the label. You don't have to attach an text annotation, but just change the label. We'll change the inputs back to 0. And then let us put the input lines, rather the connection lines. We just drag down the connection buttons. So we can tap to these lines and move this a little further because we have a not sign. Now, let's look at the first term. The first term is A, B, C, which means we will need a 3 input AND gate. To do that, we'll locate at the gates in the gate button under the circuit element, and then there's an AND gate. Okay, we pick the AND gate here and place it here above because this is ABC. This is ABC. Okay, and then the label direction should be right. Okay, we can put it up. Okay, the problem with this is it has only 2 bits input size. We need A, B, and C, so 3-bit input size. To do that, we'll click at the element and then go over to the properties panel and change the input size by clicking the plus sign. It's now C, or rather 3. So first we'll connect this to A, like that, and then we'll connect this to B, and then we'll connect this to C. I'm sorry, that's not the C. We just have to delete that line by clicking on it and pressing delete. We'll do that again. So that's a C. The second component is B and C. So therefore, we need a 2 input AND gate. Put that here. Where's the name here? We change the name. The name is gone when we deleted the connection. So that the label direction is up. I'm sorry. The second is B and C. So we'll change this to B and C, and the input size is already okay. So we need to connect this to B. Sorry, let's change the label direction first. We'll connect this to B, and then we'll connect this to C. And the next is a NOT B and a NOT C. So therefore, we will need two NOT gates. We'll get it also from the gate, from the gate elements bottom, and then we'll connect the first to B. Then we'll put a down line. We'll do the same thing to that NOT to C, so we'll have an access to C. So the third gate is a NOT B and a NOT C. We already have the NOT connection, so we'll just put in a third gate and we'll call it, label it NOT B C. The first input and the label should be directed upwards. And then we'll connect the first to the NOT of B and the second to the NOT of C. And then we need an OR gate to do the plus. So we have an OR gate here. Incidentally, we need an input close to Y. We need a 3-input OR gate. So we'll just increase the input size and then make a connection. The first. You can also start at the gate itself. Then B and C will stop here. There's an excess. We can click on the connection button and press delete, and it will just stream the line for us. We'll now connect this to the nuts. Okay. Now actually, with this we can already try our inputs. No, we haven't tried. We haven't connected the outputs. We cannot try our inputs. Let's try ABC. That's 1. And we'll try a BC. That's also 1. Can we try a NOT B? 0 and a NOT C. That's also 1. So now we have created a circuit. We can actually also use this to construct the truth table itself, like by doing a binary count. But before we do that, how do we save this? Okay, to be able to save this, we'll go to project and then uh, click export as file. Export as file will ask for a file name. So we say first PV project, and then click save. Okay. It will be saved to your downloads file. Okay. Now to illustrate the point, let us clear this project. By clearing this project, we can do so by going to into project and then click clear project. It seems that it's gone, but we can easily recover it because we have saved it before. We recover the project by going to project and then import file. And then we head over to our downloads folder. There it is, the first CD project. We'll drag it there and we have the project again. In the next video, I'm going to show you how to generate the truth table using Circuitverse. Bye for now and see you then.